Got an exam question walkthrough here for alkenes reactions and mechanism. So the question looks at reactions of alkenes, nomenclature, electrophilic addition mechanism, and addition polymers. Don't forget to like and subscribe, and if you want to leave a comment, make a suggestion for some future videos, that would be great. Okay, so here's the question. It's on 3 different slides, so as usual I'll just click through. You can pause the video and then play on when you're ready for the answers. Okay, so part A, we've got to state the reagents and conditions for reaction 1. So we're looking at the functional group change, so we're going from an alkene in compound C to essentially an alcohol. So all we've done is we've added an H to this side and an OH to this side. So the reagent is steam or H2O gas, and the condition for that reaction is you need an acid catalyst, or you could specify the acid as H2SO4 or H3PO4. Part B now, so in reaction 2, compound C reacts with bromine to form compound D. We've got to give the systematic name for compound D. So it's a dichloro and it's a dibromoalkane. So there's a couple of rules we've got to remember. The alphabet rule says that the substituents in sort of lower in the alphabet should come first. So we've got bromine, so this is a 1,2-dibromo, 1,1-dichloroethane. So 1,2-dibromo, 1,1-dichloroethane. We've now got to do the mechanism for reaction 2. So reaction 2 is this reacting with bromine. So it's basically just the interaction of the double bond with the bromine molecule. That's where the sort of mechanism focuses on. So the first part of the mechanism, we have a pair of electrons being attracted to the slightly positive bromine on the Br2 molecule. Remember, the carbon-carbon double bond is a region of high electron density, and it polarizes the bromine molecule, and then the pi electrons are attracted to the slightly positive bromine. The knock-on effect of that, you can see with that second curly arrow, is it breaks the bromine covalent bond by heterolytic fission. So just remember where your curly arrows start. They must start from the middle of a covalent bond, and you can see that's the case in both of those curly arrows. Okay, so the knock-on effect of that is it's going to create a carbocation. Now I've chosen to put the bromine onto the first carbon, or the left-hand carbon there. Obviously that means there's a positive charge on this carbon, and what's left is the Br that's broken off is a Br minus, so that attaches itself via a pair of electrons. So we're showing the lone pair on the Br minus, and the curly arrow must go from that lone pair to that carbon with the positive charge. Now, depending on which exam board you do, I know AQA insist on what's on the screen now. OCR would actually allow a curly arrow to go from the minus charge of the bromide ion onto the carbon. I'm just going to show you the other way of representing this stage. So basically it's that where we put the bromine on this carbon, the one with the chlorines on, and you see the second curly arrow from that lone pair on the Br minus going onto that carbon with the positive charge. So either of those, absolutely fine. And then obviously that's going to give you your product. Okay, so the final part of the question, we've got to write an equation for the conversion of compound C, this thing here, into the addition polymer E. So obviously what we do is we're going to break this carbon-carbon double bond. We're going to put end bonds on each side of the carbon, and we're going to wrap it in a square bracket. So that would be represented like that. Don't forget your little ends there, which means that there's a large number of these molecules involved, and obviously this repeats itself, so there's a large number of repetitions of this. Remember, those end bonds have to poke through the bracket. And the final part of the question, state one advantage and one disadvantage of using combustion as a method of disposal of this waste polymer. So there's a few things you could say. Any one of these would be fine. Less reliance on fossil fuels, less waste going into landfill, or the energy that's recovered from the combustion can be used for electricity production. Disadvantages now. So obviously this polymer contains chlorine, so that could lead to the formation of HCl, hydrogen chloride, which is a toxic gas. You could form carbon dioxide, obviously, from the combustion of the carbons. Obviously that's a greenhouse gas, so there's two ways of kind of phrasing that. And also, if the combustion is incomplete, you run the risk of forming toxic carbon monoxide. So anything like those is fine. If you've got something different, just put a comment in the comment section and I'll get back to you to tell you whether it's okay or not.